Hello and welcome to our presentation for the IBM Watson Analytics Competition. We represent the University of Derby. I am Thomas Robson and these are my colleagues Claire Barrett and Jake Tuck. The first graph is a graph from NASA which shows the temperature of the ocean and land globally from 1880 to 2016. By inspection, typically the temperature has been increasing on average, apart from a few blips which came around in the 1910s. The second graph on your right shows the total column ozone in 2017. From the colour scheme in the picture, you can see that the ozone layer has had certain depletion, especially around the outer layers where it drops to around 200 Dobson units. Our case study for our investigation is basically based in Scotland. In order to correctly understand the data sets, we must first embark in understanding what problem areas the government of Scotland has targeted as key contributors to the carbon footprint. The government has set targets for 2032. I think they were based from 2012, so as in the next 20 years. As you can see on the slide, some of the more ambitious targets include wholly decarbonising the electricity system by 2030, vastly reducing transport emissions by 32% by 2032, and massively reducing food waste by a whopping 50%. Based on the previous slide, our overall aim is to evaluate the Scottish Government's proposal and to produce any recommendations based on the statistical and predictive analysis performed by IBM Watson Analytics. To meet this aim, our objectives are to determine the top three main greenhouse gas emissions, to evaluate if there is a correlation between greenhouse gases, temperature, carbon footprint and ozone measurement, to use the reviewal of the Scottish proposal to enhance our final recommendations, and finally to discover any new insights by using predictive as well as statistical analysis that are helpful for future environmental work.
So to allow the analysis of greenhouse gases, we had a number of data sets that the Scottish Government had been using for their predictions and recommendations. So the data sets that we used were around temperature, ozone measurement, the total greenhouse gases emitted, and different producers of greenhouse gases. We've got the salinity of the sea, and we've also got the carbon footprint as well. So the first graph we looked at is analysing the greenhouse gases, and we use a stacked graph analysis because then we could see how the greenhouse gases have been over the last few years, and as you can see they are decreasing, and we also were able to see what the main contributors were. So the top three were energy supply at 32%, agriculture at 21% and transport at 16%. And this matches what the Scottish Government have found, they are the three top main contributors in their report as well. So the next analysis we performed was looking at the relationship between top three producers of greenhouse gases and the column ozone measurement. So the graph we used for this was a combination graph. We thought this suited better so we could see both of the data sets quite clearly, and a correlation is shown in general between the top three producers of greenhouse gases and ozone measurement, and this is to be expected. The next one we did was the combination graph around the top three producers and average surface temperature, and a correlation is slightly shown between those, which is to be expected. And then we decided to move on and look at the total carbon footprint. So again we used the combination graph, but which was not to be expected. We actually found no correlation between the total carbon footprint and the top three producers of greenhouse gases. We thought this was possibly because there's one main contributing factor. So we decided to do a couple of graphs looking at the top three individually versus the carbon footprint. And the main contributor we found was the transport data. So as you can see for this, the graph on the slide, you can clearly see a correlation between the total carbon footprint and the transport data. As well as looking at the top three, we also had a look at other producers of the greenhouse gases, looking at if there's any other areas for cause for concern. And one area we found was international aviation. And as you can see from the bar chart on the right, it shows that international aviation has been highly increasing between 2002 and 2009. Now, the reason why this is a main concern is international aviation and shipping releases carbon dioxide and nitrous oxide. And nitrous oxide can cause health problems and increase in global warming, and also carbon dioxide can increase the salinity of the ocean, which then can cause problems with habitats and migration. Albeit Scotland's efforts to reduce international aviation, as shown on the previous slide, it did cause a reduction until 2002, but because there's such a great increase from 2002 onwards, we believe this is a main area of concern. So other areas of concern found as well, we used a line graph to look at the salinity of the Scottish continental shelf, the Fair Isle Current and the Central North Sea between the time period of 1998 and 2009. And apart from the Fair Isle Current, which is showed to be fluctuating, there is an increase in salinity over those years, and salinity is mainly caused by carbon dioxide, which it links with the carbon footprint. So that was another area of concern we found. We decided next to do the predictive analysis to look at what drives column ozone measurement and other factors. So the column ozone measurement drivers calculated by Watson Analytics was the Scottish continental shelf, the salinity and Fair Isle Current temperature, and these can't really be a driver, but it has been shown by Watson Analytics that it is correlated. There must be a contributing factor for both, which they share. The other drivers calculated were all producers of greenhouse gases, which is to be expected, and carbon footprint directly produced by Scottish residents, which is quite interesting because it doesn't pick up the total carbon footprint as one of the main top drivers. In regards to average surface temperature, the top drivers calculated were all producers of greenhouse gases and total carbon footprint, which is to be expected. And again, it picks up on the salinity of the Fair Isle, Scottish continental shelf and Central North Sea, which means obviously there must be a main contributing factor that links column ozone between those and the average surface temperature. The last predictive analysis we did was around carbon footprint. So the top drivers calculated were greenhouse gases produced by transport, energy and agriculture, which is to be expected, and greenhouse gases produced by public sector, which is to be expected in certain areas, but it's not one of the main producers for greenhouse gases. So it's interesting that Watson's been able to pick up on this. And it's also been able to pick up on greenhouse gases produced by forestry and carbon footprint embedded in imported goods and services.
From the graphs shown in this presentation, it is possible to draw some conclusions from these analysis results. The main points of summary can be seen on this slide. The main point for this is the international aviation and shipping emissions have increased and is seen by the Scottish Government to be a minor problem, but because of the health impacts associated, it should be carefully looked at as an important issue. In general, the results obtained from this analysis support the Scottish Government policy, and they have identified international aviation as a cause for transport emissions. However, as explained previously, the issue of international aviation is still seen as less of a priority compared to the other main contributors to Scotland's carbon footprint. Furthermore, as shown by Watson Analytics, public sector emissions are a driver for Scotland's carbon footprint, and by inspection of the line graph on this slide, the salinity of the sea surrounding Scotland is increasing, and this could be related to the increase of the carbon emissions. Scotland is already planning to advise the public in ways to reduce their emissions. From this investigation, we have two recommendations for the Scottish Government. The first being around the issue of international aviation, and the second focusing on the public sector emission targets, such that the Scottish Government need to readdress the importance of these two highlighted contributors, as they are not being identified as key contributors to Scotland's carbon footprint. From myself and from the team, we would like to thank you for listening to this presentation, and we hope you enjoyed it. And these are the references for the work.